Yeah, thank you very much. I'm Alex Mindell. I'm DfT's head of AI and autonomy, and I also sit in the science, innovation, and technology division. And I've been leading on our transport AI strategy, which should hopefully be coming out in the next month or two. I've only got 10 minutes, so this is going to be a bit of a whistle-stop tour of AI. I'll give a bit of a background on AI, where we are now, what the future is looking like, why this is important for transport, look a little bit at the challenges, and then a little bit around the high-level details of the strategy. So first of all, what is AI? So AI is machines that perform tasks normally requiring human intelligence. So this is from our national AI strategy. It's quite a broad definition, so it's important to note that. And I think I want to make a couple of points with the pictures on the bottom here. So this has really come into the public consciousness since ChatGPT got launched in November 2022. But there's another picture down here from Deep Blue in 1997 when it beat the world champion Garry Kasparov. So AI has been around for a really long time. It's been around for almost 70 years now. And we've started to see a trend from moving from more narrow uses of AI. So here you'll see, Deep Blue was only good at playing chess. It was very good at that specific task, but that was all it was good at. Whereas now we're getting more modern versions of AI, which are more generally good at a number of different tasks, as seen by ChatGPT. And the other thing that I'd like to mention is how ubiquitous AI is becoming. So every time you go on your phones, every time you use Google Maps, there are machine learning algorithms that help to decide, what is the best route for you? What journey should I take, which will take the least amount of time based on current traffic data. Every time you use Spotify and get a recommendation of a song, that is using clustering algorithms to better understand your tastes. So it's really important that we understand this issue, some of the challenges that go with it, and the potential for transport. So the building blocks of AI, we heard recently about the transport data strategy just earlier from Matt Coleman, and we really want to build upon that transport data strategy because data is the lifeblood that AI works upon. It's a huge and really important area, and we're getting increasing amounts of data all the time at the moment. We're also getting new algorithms. So you'll have seen this new version of large language models, all of this, ChatGPT, and all of those natural language processing that you've seen run on a new architecture. This is a transformer architecture. It was only actually invented around 6 years ago by Google. And we're also seeing massive increases in compute power. So to give you a bit of perspective on how much of an increase in compute power we're seeing, you'll have all heard of Moore's law. If you had a battery back in 2012 that lasted a day, by 2020, if it had increased at the same amount of computing power, that would last 280,000 years. So that gives you a bit of a context for how much computing power has increased, and that's really driven a lot of these advances in AI. So what does this look like? So to give you a bit of a pictorial picture of what it looks like. Back in 2014, it was hard for AI to even construct a realistic looking face. By 2018, it could do a pretty good job of that. And then more recently, back in kind of 2022, 2023, with the launch of things like DALL-E and Midjourney, you can put in now quite complicated prompts. So here, one of my colleagues got his kid to play with one of these and came up with giant cat demon flying because of its giant gas explosion. And you can see, the kind of art and pictures that it can create. And you'll have all seen some of the photorealistic deep fakes and other pictures that can be created by AI at the moment. So what's on the horizon? And I hope this works. Never good using a video in your presentations, but hopefully this works. So this is from OpenAI's new Sora model. So we're starting to see a movement from pictures to also including videos. So this is a really simple prompt. reflections in the window of a train traveling through the Tokyo suburbs. So you can see how realistic this video looks, like completely, unable to tell the difference between that and a real video that someone might take on the train. This model isn't yet open to the public, but is, an interesting case in point of kind of what's coming. And I think a lot of this is also going towards being more multimodal. So we'll start to see these sorts of models where they'll combine the text, the image data, and the video data all together to create these larger multimodal models. And we're also starting to see more agent-based AI coming along. And it's worth noting that this is kind of the worst that this technology will be. Obviously, this is a hand-picked video from OpenAI. There are still lots of issues with this, such as there's a few examples of kind of generating these videos and people walking like backwards on a treadmill and those sorts of issues still around. But these are starting to get better and starting to be built up. So what does this mean for the transport sector? And I'll quickly go through a few areas and use cases that we're starting to see. So a big one is around optimization. You heard earlier about the Intelligent Traffic Management Fund. So route optimization across all of the modes of transport is going to be a massive area for this. So not only on our roads, but also in our skies. This is a project from NATS called Project Bluebird, looking at how we can be more efficient in terms of optimization of air traffic control, and also in our waterways. How we move freight around the country, and also things like rail timetabling. These can all be optimized greatly using AI, and how we recover as well from disruptions. So when a disruption happens, what's the best strategy for alleviating that disruption for the public? These are all things that AI is really good at, especially using historical and real-time data. So next is around planning. So we heard a little bit about EV chargers. So a big thing that you can do and that the department is currently looking at is where we place our EV chargers. So can we use, for instance, geospatial data of where HGVs are, tend to be on the network to better understand where we should put our EV chargers. So we've seen a lot around the kind of planning side, where could we put a new bus route, where could we build a new train station. Those are all really important things and areas that AI can help with. Another thing that was mentioned earlier was the AV bill. This is a huge area for the department. 88% of reported accidents involve human error as a contributing factor. So this is a massive area where safety can really improve us and also create lots of efficiencies and growth for our economy. But another area that's maybe less talked about is in the construction industry. So massive for transport, huge amount of construction around our infrastructure, and how can we create this to be better, using connected autonomous construction plant. We see this as a huge area as well. And we're also starting to see automation coming along in some of the other sectors, including maritime and aviation. Another huge area for the department and the sector as a whole is around automated inspection. So this is from a Network Rail project on automated inspection of vegetation encroachment. So it uses really simple technology. You just strap a camera to the front of your train, you use some satellite imagery, and you can quickly get a computer vision algorithm to mark where you're getting vegetation encroachment, and then you can prioritize the areas which need to be cut back as much as possible. And this really improves the safety. You have less people on the line at some time, and you can also increase efficiency by prioritizing the areas that need it most. We're starting to see this on the roads as well, with potholes, and starting to become more into the predictive maintenance space. Can we spot a crack before it becomes a pothole? How can we use AI to understand some of that? And then we're starting to see more applications of generative AI. So the stuff that I spoke about earlier around that becoming a bigger area, but these are mostly more, this is a much more nascent technology, and so these are slightly less developed, and these are mostly around the internal use of AI within DfT and within transport agencies and within industry bodies. So these tend to be things like speeding up the delivery of services. How do we better retrieve information and route queries? How can we, help our staff do jobs by creating first drafts, consultation, correspondence, and things like that. But this doesn't come without its challenges, and there are huge numbers of challenges for AI. Obviously, data is a huge one. Data access, data availability, data quality all really matter. We've all seen lots around kind of bias and bias AI. You may have seen Gemini recently, where they had kind of used historical data, realized that there was some bias in the data that they used, and then they had issues with how they tried to fix that. So when you asked Gemini to create images of a historical context, it would basically get things entirely wrong. So you would ask it for a picture of an SS soldier, a Nazi, and it would come back with people, who are black or Asian, etc., because they've tried to correct this after the case with, following that biased data. Another big area is outlier events. So a big issue for AVs, there's essentially an infinite possibility of things that could happen on the roads, and trying to train a machine learning model on everything that could possibly happen is obviously very difficult. And then also black box and explainability. So these are very complicated algorithms, and understanding exactly how they make some of these decisions is very difficult, and it's a very nascent area still, trying to make AI more explainable. So quickly on the AI strategy. So this is really about creating the foundations for the sector, for this rapid change that I've just explained. And our vision is responsible AI embedded in a resilient transport system, delivering cheaper, cleaner, and quicker journeys for all. So this encompasses DfT's strategic aims, really improving the transport for the user. We want to reduce our environmental impact using AI, and we want a more resilient transport system. And you can see on the right here, this covers some of the themes that I spoke about, and that will come up in the strategy. And also our 4 objectives are in the circles. So the more internally facing objective, so utilizing AI to enhance the quality, efficiency, and effectiveness of DfT. So that's, using AI to help the department do its job better. In the top right, we have adopt AI responsibly to deliver better transport for all. So that's really around improving transport for the user and that user-centered focus. Our more externally focused international one around securing the UK at the forefront of transport-related AI applications. And then lastly, around, which I think is really important to note, is around maximizing our economic benefit from AI in transport, but also doing that whilst reducing transport's environmental impact. So AI has huge potentials for reducing our environmental impact, but also you will have seen recently that AI does use a huge amount of compute, which also comes with its environmental consequences. So this is something you should be looking forward to in the next couple of months. And we're really hoping for industry to lean into this AI strategy, and also looking to work more closely with local authorities on this. So the 5 areas as a quick overview. So we've got 29 actions under these areas. So leadership, engagement, infrastructure and data, application, skills and capabilities, and how we're really going to drive impact on this. So as I've said, we're looking to set the foundations, prepare the sector and the department for this rapid change. We want this to act as a clear signal to industry, show our commitment to engaging with all of you and embedding AI in transport responsibly. We want to contextualize and reinforce that data journey that the sector needs to go on and build on the transport data strategy, and really identify where the rapidly evolving capabilities of AI are and where they can be applied to transport going forward. Thank you very much.